Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll be looking at data cleaning, in particular using edit rules to check whether your variables meet the natural constraints that those variable values should take. So here we are at the course website. I'm going to scroll down to the timetable. And at the end, we'll be coming back to my example homework document. So we'll come back here in a moment and get down to data cleaning. So data cleaning, the chapter here we'll be looking at is chapter 11. And I encourage you to open up the R code so that you can follow along. I'm going to switch over to the PDF file for this chapter. And there's tons of awesome information in this chapter about data cleaning. And in particular, one of the reasons we start Advanced Data Analysis 1 with looking at a very large data set, thinking about variables, making our own code book, making a subset of our data, all these sorts of data handling issues is very much a big part of doing statistical analysis. In fact, if any of you ultimately become statisticians or data scientists or have that sort of title, you'll find that probably about 70 to 80% of your work is just dealing with data, reshaping it, cleaning it, organizing it, coding it, all that stuff. So there's tons of cool things to learn about. I'm going to scroll down a bit and see that this is basically the statistical analysis pipeline. And there's 5 steps here, and 3 of them have to do with data cleaning. Getting the raw data into your computer, checking what the data types are, whether they're categorical, whether they're logical, whether they're numerical, normalizing it so that they're in the correct format. Then that gives you technically correct data, but then there might be data values that are incorrect. So then you need to fix those. If there's missing values, you can impute them. And imputation is just sort of a type of prediction for missing values in a data set. And that will get you to consistent data. Once you've got data that you're happy with, then the stuff that we often think of as statistical analysis can commence. We can estimate values, analyze the data, derive quantities, have our results, tabulate and plot those so that we can communicate them, and then finally have some sort of formatted report to communicate the results to others. But boy, a large chunk of this is data cleaning. So there's tons of information in here. I really recommend that you skim it at least and have a sense of some of the topics that are involved in data cleaning. You may find yourself in your future, as you're dealing with bigger projects that are much more important to get correct with data that is far messier than I've provided you, you may find yourself coming back to this chapter and really digging in to understand how to easily make sense of your data and make sure that it is correct before you publish results from data that are messy and wrong. All right, so I'm just going to page down like crazy. In fact, I'm going to jump down to section 11.5.2, which is about edit rules. So as you can see where my scroll bar is in the bottom right-hand corner, we're 3/4 of the way through the chapter. We're just going to, in this class, think about a simple process for defining rules and then checking which observations in the data set violate those rules and then correcting those manually. All right, so edit rules are just just a way of saying what the data should look like. And I'm going to scroll through this quite quickly. In fact, I'm going to focus on this one example. So on the course website, this was originally developed for the second semester of this course. There is a data set, and I'm going to just go to the browser and open up that file. It looks like this. There's It looks sort of messy because it's not all spaced out, but there's 5 columns here, if we go back to the notes, I'm going to assign this file location, which happens to be on the web, to fn.data, that's the file name for this data set, and using read.csv to read a comma-separated values file, it's going to read this file, and there's lots of defaults in read.csv which are all happen to be correct for the data set that I actually put together here. And I'm going to put that into this object called people, and then I'll print that to the screen. We see that we've got 5 columns, and it's about people. We've got their ages, their age group, so this is a category based on what their age is, their height in feet, their marriage status, and how many years they've been married. Okay, and you can already see as you start scrolling through this data that there's definitely some values here that are incorrect. You know, there's a 21-year-old adult who's 6 feet tall and single. That looks good so far, but they've been married -1 years. There's a 2-year-old child whose height is 3 feet and they've been married, but the years they've been married is 0. So the child can't be married. 18-year-old adult, 5'7", married for 20 years. Oh, 20 years, but they're only 18 years old, so that seems incorrect, and so on, right? And so our goal is to imagine that, in fact, this is just 5 records of a data file that's maybe 20,000 observations long. You can't manually go through and look at this. We're going to automate this. And we're going to do that by defining edit rules. This is in a package called edit rules. And I'm going to scroll down a little bit. I'm going to skip some of that stuff and get down to, let's see, get down to this part of it. All right. So on the website, no, this is fine. We'll stay here. All right. What are some sensible rules for the data set that we saw above? Let me page back up just for a moment. We've got age, age group, height, status, and years married. So we've got 3 numeric variables, 2 categorical variables, and they're sensible values for each of those. So let's use our common sense and make some rules. And all of these lines right here are going to be in a file. In fact, I'll just show it to you now. Just page down 1 page. And I'll open this in the browser. And you shouldn't put quotes around a URL. Here we go. So this is a text file. This is called ADA2 Notes Chapter 18 Edits.txt, and it's just a text file with 15 or so rows and this text in it. So this is exactly the file that's going to be read into our edit rules. So let me page back up 1 page and look at some of these rules. We have age has to be at least 0. Good, no negative ages. Heights need to be positive. Ages can't be greater than 150. Now that probably seems high to you. Pick your own maximum age. If you want to make sure that people don't live older than 105, then that's fine too. And furthermore, your age should be at least as old as you are married. Hopefully at least 18 years older than that. Okay, so there's some numerical rules. How about some categorical rules? For example, your status, your marriage status, should be one of these 3. You've been married, you're single, or you're widowed, where you lost your partner. Age group, there's 3 of those. There's a child, adult, or elderly. And the case here of all lowercase matters. We actually don't have that issue. If I page up for a moment, everything here is lowercase. But if this was a different case, if single started with a capital S, that would be an issue. Okay. Furthermore, if your status is married, then your age group should be contained in this list, either adult or elderly. So we're going to make sure that children aren't getting married. And finally, there's some more mixed rules. In fact, this if statement should probably be part of the mixed rules category. We've got that your status, if it's in married or widowed, then you've been married at least once. In that case, your age minus your years married should be at least 17, meaning that you were at least 17 years old when you got married. And then three other rules which basically say that define your age group by your age number. So if you're younger than 18, you're a child. If you're between 18 and 65, you're an adult, and if you're 65 and older, you're elderly. All right, so those are our rules. And there may be more to define, okay, but I'm just showing you a subset to get started with. So as we just saw, all those rules are contained in this file. And we're going to read that file with edit file and put that into E. So by running edit file, we have read those rules in, and the computer has interpreted them into a set of rules the computer now understands, and we'll use those edit rules in a moment to test our data. If we print out E, it tells us how it interpreted the rules and gives them each names. So here it says that there's two rules based on just the data model, and so that basically says that age group has to be in one of these three categories, the status variable needs to be in one of these three categories, and then there's edit sets, which include numeric variables, categorical, and mixed variables. So here's our numeric rules. Numeric 1 is that your age has to be greater than or equal to 0, and so on, right? And one thing that I just noticed, actually, is that these mixed rules, if I page up for a moment, notice we had if the age is less than 18, then the age group equals child. That got interpreted slightly differently. If I page back down, it got interpreted as if you're less than 18, then your age group is, and the exclamation point in front says not, your age group is not in the elderly or adult groups. And so that's how it interpreted equal to child. It's okay, it will work out. We know that that is equivalent because there's another rule up here that says the age group has to be one of these three categories. So if it's not if it's not adult or elderly, then it must be child. So those two rules together make sure that if we go page up for a second, that this is equivalent to the statement we had originally. All right. So you can actually plot these rules. So this code here creates a plot for this rule. In fact, plot E here is what we're plotting. We're plotting the edit rules. This other code around it, just for a moment, I'm going to change my graphic parameters to have no margins so that the plot can take up the entire space. And mfrow says that if we have previously defined a multi-figure panel, that this multi-figure is going to have one row and one column, which says it's going to have one plotting space. And so the plot that we see is this one, and the other two lines around it says if whatever the graphic parameters were, OP is for original parameters, it's going to save those original parameters, then it's going to make a change to the parameters, and then it's going to restore those original plot settings. So this is one strategy for if you've set up your plots to look a certain way, this allows you to make a temporary change but then go back to those settings. Okay, not a big deal. All right, so let's keep going. Here's our plot. There's two symbols and then there's lines connecting here. These blue circles indicate the variables. So there's 5 blue circles. Those are our 5 variables. The yellow squares indicate rules, and they have the label of the rule on them. So num2 is the rule that applies to height. It's connected with a bar. So let's page up and just take a look at rule number 2. Number 2 is height is less or height is greater than 0. And that's the only rule having to do with height. If I page back down, that's what we see. So this is a quick way to make sure that you've got rules for all your variables, and also to have a sense of how complex some of your rules are. For example, mix 6 deals with age, years married, and stat in your marriage status. So let's go take a quick look at mix 6. It's got age, years married, and status, all in one rule. Okay, so that's our visual summary. This is not an important plot. You may plot it out, you may print it out maybe once or twice just to take a look, and then maybe you comment this code out because it's just taking up space. All right, let me keep paging down. Here's the interesting part. So once we've defined our edit rules in E, and we've got our data set people, now violated edits is going to summarize what observations had violations of those edit rules. Furthermore, it'll also summarize what rules were violated the most. So I'm going to assign violated edits to VE, and if we summarize that, the first summary is what the edit names are, so category 5 for example. Of our 5 observations total, we had 2 of those 5 that violated cat 5. And the relative frequency, 2 of 5, is 40% of our data violated that rule. Mix 6, same thing, 2 violations. And this table will be sorted in descending order by the number of times each rule was violated. There's also a second summary which says how many observations had how many errors, sort of a less important plot. You can plot the violated edits. This is what it looks like. It looks like a bar plot. It says 40% of the observations violated the category 5 edit rule, and so on. It says frequency down here, but it's really proportion. All right, not important. All right, so let's keep going. And I think this is the point where I want to start doing a few things actually in R, and we'll look at this data here, but I'd rather do that in R. So I've moved this over to R. I've copied the relevant code into the editor window in the top here, and my cursor is up here on the first line. And we've learned before that if I press Control Enter, it will copy that line from the top down to the console and then execute it. I'm going to do that a couple times. I've read the data into people. There's the data set. Now I'm going to press Control Enter a couple times, and actually this is an edit rule that we don't care about, so I'm going to ignore that. All right, I'm going to read in the data file and assign it to E. Here's the edit rules. This is the same list that we just saw in the lecture notes. We can plot it. Okay, I don't have my window big enough for it to look very good. Oh, I guess I could plot this too. There's our, I think that every time you run this, it should probably look a little bit different. Yeah, so how it arranges the graph will change each time you compile your code, but it's not important. It will always show the same information. All right. All right, I'm going to do something a little bit different than the notes. I'm not going to worry too much about these. That's okay. Let's do this. So ID 2 and 5, that's the second and fifth observation in the data set. So people ID says I'm printing the second and the fifth row. So down here in the console I've got the second and fifth row, and that's the data set down here. And I've got age 2, who's a child, height is 3 feet, married, years married 0. Seems to me maybe married is the wrong one here. Who knows? We can We'll take a look at that in a moment. For number 5, we have a person who's 34, who's a child. That's not quite right. Height -7, that doesn't seem right. Married for 3 years. All right, so maybe their height is wrong, and maybe they're not a child, but maybe they're an adult. For this top one, maybe they're not married, but maybe they're single as a child. All right, so let me, for just these two, run this violated edits line and output that just to the screen. What this does, this table, is you can see the columns are each edit rules, and then below is true or false of whether there were violations. And in this case, we've got 2 for record 2 that were violations: the category 5 and the mix 6. All right, so I'm going to leave this here, and I'm going to jump over to the notes so I can have the rules and the data up at the same time, though I won't rearrange it to look at it both at the same time. So category 5, mix 6. Category 5, mix 6. Here it says if you're a child, you can't be married, but this child is married. Okay? And then mix 6 says that if your age is less than years married plus 17, then you can't be married or widowed, meaning that if you are basically 17 years and younger, you need to be a child, and that this child is married. Okay, so that's those 2 rules. You can go through the same thing for the 5th one here and find these 3 edit rules that were violated. At the end of the day, you need to do some manual corrections, and here's probably the simplest way to do that. For record number 2, I'm going to edit the status, and I'm going to change it to single. That would be changing the status for this child to single. So I'm going to run that line. And then for the second person, let's treat -7 like it should have been a +7. That seems like a very simple change. Furthermore, someone who is married for 3 years and is 34, let's just change that to an adult. So these 2, the age group and the height, seem to be the most logical ones to change. So I'm going to run those 2. We can print out the new data set. In fact, if we just restrict it to these 2, here's the smaller new data set that's been corrected. Notice that the child is now single, and the 34-year-old now is an adult with a +7 height. Great. If we run the edit rules again, that's this line that I highlighted, it says no violations detected. You give yourself a high five, and you're done. So one really nice feature of writing all of your code is reproducibility. That is a major feature of how I teach this class. We're using Markdown in R, we're writing our code chunks. We are never editing the original data file. We read the data file in, we take it as it is with all of its flaws, and then we're going to record all of the changes that we make to it in our code. So imagine that you inherited an Excel spreadsheet from someone, all right? And you read the data in and it had some errors. If you go into the Excel spreadsheet and you start editing manually all of the cells, a week later, a month later, 2 years later, when you need to answer the question, what did I do? You have no record of it. So that's why writing code and doing this sort of thing says exactly what you did, and it says why you did it. I made these changes because it violated these edit rules that are uniform for all my observations. So that's really important. All right, one more thing. In fact, let me go back and I'm going to read in my original data file. I'm going to take away those corrections. Okay, so if we let's look at the violated edits for everyone. All right, so that's this right here. This is for the entire table. So let me clear my console. Command L clears the console. All right, so there's my original data file. Here's my violated edits. And each row represents each observation. So I might want to know which observations have at least one violated edit. That's a very natural question to ask. I've got 40,000 records, imagine, right? How many of them have violated edits? And which ones are they? So one strategy to do that is numerically, false equals 0 and true equals 1. So for example, if I want to add up some trues and falses, true, false, false, true. Okay, if I want to add those up, it will equal 2, because once I apply some type of numeric computation to trues and falses, the true false gets converted to ones and zeros first, and then the operation is performed. So one strategy on this matrix, really what I want to do is I want to calculate the sum over each row. I want to add up all of those falses and get a 0. So here's a function. It's called row capital sums, which will do exactly that. So I'm going to run that line. 1, 2, 3, 4, 5, that's the row number. And then 0, 2, 2, 1, 3 are the number of violations. And if you want to check the computer's work, you can look up in the table and spend a moment to do that. So that's one way to answer the question, how many violations does each row have? And then I guess you could do something with that to ask how many violations do you have? For example, you could ask, of those, how many are greater than 0? And then you could add those up. All right, so that's just one way to do that. So that is all I want to really cover in the lecture notes. I'm paging down here. There is a section on correction. Actually, I stop at correction. All right, there is something called, I know I'm jumping up and down here, it's impossible to follow me. There's something called error localization. And there's a strategy for basically having the computer answer the question, what's the minimum number of changes I need to make to each observation to satisfy all of the edit rules? Because parsimony or simplicity is probably the best strategy, meaning errors happen, but not many errors. And so it's likely that very few errors, you can correct very few errors, and that's maybe the best solution. Anyway, so there's a section on that which you can look at too. All right, let's go now to the course website. And if we go just above the timetable, there's my example homework document. And I'm going to click into the HTML now. And in there, I'm going to scroll down to data cleaning happens in week 4. And so because of the order of operations I want to perform on the data set, it actually got sort of stuck in here inside of the week 3 stuff. All right. So in terms of our process so far, we've defined our personal codebook from our large data sets. We've done a short literature review, including some citations. And then we have created our own, we've defined our variables, created a variable, a small subset of the data. We've renamed those variable names, which was like H4 whatever, from, for example, add health wave 4, to some more meaningful variable name. We've coded missing values. We've labeled our variables. For example, if you had like a sex variable that was defined as a 1 and a 2 for males and females, you've labeled the coded values 1 and 2 to have the labels male and female. Okay, but even before you do all that, I think once you rename the variables, now's the time to clean the data before you do any additional processing. Get everything correct at that point. So I'm going to click on data cleaning. It will jump me down there. And this takes us through this process for the NESARC data for the questions that I had. And there's notice how much writing there is here. I'm not going to read this to you. Take the time to read through this and understand what I'm doing. All the details are here. But maybe here's the main points. I've saved this edit rules document to this computer. If I go back to the web page, the edit rules file is right here. I'll open that up in a new tab, and there's all my edit rules. It's a bit bigger than the example in the notes, but there's a lot of comments here. Nothing happens in this first set of code. This is all just notes to help you understand what I'm doing. I use this in operator anytime I'm asking whether a value or a variable has values within a certain range. For example, sex needs to be 1 or 2. It can't be 1.5. So I don't want to use, greater than or equal to 1 and less than or equal to 2, because any value between 1 and 2 would also be fine. It needs to be either a 1 or a 2, nothing else. So this is giving me that list. Same thing for age. Ages happen to be integers. In fact, almost all this data here are integers. So that's where these categories are coming from. Here's a way to specify a range plus another number. So this, in smoking frequency, I'm taking all these values exactly from the code book. The numbers are defined as 1, 2, 3, 4, 5, and 6. Those mean something. And then number 9 is like a missing or refuse to answer type answer. And so that gives me that range of numbers, 0 through 6. Then I'm skipping 7 and 8, and then including 9. And notice, you may find this to be a little bit odd, that I'm doing daily cigarettes smoked from 0 to 98 and then 99 separately. That's because 99 has a different meaning, and I'm the sort of person who wants to look at this and see that I'm addressing that separate meaning of 99 distinctly from the other numbers. So that's reminding me that, oh yeah, there's a missing value in the data set. That 0 through 98 means something numeric, 99 has a special meaning. All right. Will it work if you do 0 to 99? Absolutely. It'll work exactly the same. It's equivalent. Okay, these are just me and my quirks. I'm uncovering all my faults. All of them. All right. One last thing here. The ID number has to be in this range because there were 43,000 participants. They all had a unique ID number, sequential from 1 up to 43,000. And so all their ID numbers are actually in that list. That's great, but who cares? Like, ID numbers need to be unique, but there's not a special range. So there's a couple reasons why I commented it. One is we don't care, but the second is it takes a long time. If you do this, it will, for every observation, every 43,000 observations, it looks through to make sure that the ID number is in this long list of integers, 43,000. So it ends up taking like 20 or 30 minutes, and you'll feel sad after you run that 2 or 3 times. So ignore that. Just comment that out. Everything else, I've just taken my variables directly as they are from the codebook, put in the admissible values from the codebook, and then I run it. I have a couple additional rules down here. I'm dealing with smokers. So I say that smokers, if the smoking status is 1, which means that they smoke, then their smoking frequency can't be equal to 0. So they need to smoke a little bit if they smoke. Furthermore, their daily cigarette smoked can't be 0 also if they're smoking. So those are 2 additional rules. And we haven't done a lot of this yet in the class, but you may at some point want to construct other variables. So I've constructed variables like how many days does a person smoke, what's the total cigarettes they smoked, and these are basically just functions of their other variables. Okay, so if I know the daily cigarettes smoked and I know the smoking frequency, then I can maybe multiply those together to get the total cigarettes that they smoke in a period of time. All right, so these are variables I've calculated, and I could have additional rules for these constructed variables, but because they come from my original variables, as long as my original variables are correct, these should also be correct. All right, so plenty said there. To go back to the rules, and I think I'm not going to do very much more on this video on this, but I will strongly encourage you to read this and take a look at what the results are, see that they make sense, and then apply them to your own problem. In my case, I've got some violations for my data, where actually 58% of the data violate some of these rules. Okay, DAT2, 6, and 7 are the major culprits, and they all have the same relative frequency. Probably the same error is contributing to all three. DAT2, 6, and 7. Let me scroll up for a second. DAT2, here's 6 and 7 anyway. DAT2 is number as daily cigarettes smoked. All right, so maybe I'm getting some daily cigarettes smoked that aren't in this list, and same thing here. My suspicion is that some of them are probably coded as missing values already, NAs, and an NA is different than any of those integers. So if that's the case, I would want to verify that actually 58% of my data are missing values, right? So there's going to be some steps I take here to actually check this, and in fact that's what this is. I'm checking whether I've got lots of missing values, and in fact that the missing values are the same ones that are violating these edit rules, and that true is saying yes, all of those violations are due to NAs, and I didn't have any other errors, so I've caught all of them. There's some additional things here. I don't need to correct any of my errors. Our data sets are actually pretty clean. I would be surprised if you needed to make any corrections, but please let me know in class if that is the case. And that's all of it. So the main part here is just defining this edit rules file, and then checking to see what errors you get. And if you get any errors, to take one more step and to see whether those errors make sense. In my case, they were actually all missing values. These were all missing values, but in your case, they may not be. Maybe something is actually coded incorrectly. For example, if you merge the two Add Health data sets from Add Health Wave 1 and Wave 4, you might check, are the birth dates all the same? Are the genders all the same? Now, gender might actually change. People identify differently, possibly when they get older. But you might check a few things just to see if they make sense. All right? I encourage you to do a little bit and not overdo it. The point is to get a little bit of experience and to know how to do it later in life, and not to spend 10 hours over your valuable weekend to apply to this data set. All right, so that is everything for data cleaning for this class.